Okay, here's a tutorial on how to use the Austin Community Greenhouse Gas Emissions Dashboard for the Community Climate Plan rewrite. So we made a graph showing actual emissions in the community here on the left side of this dotted line, and then our guesses at possible future emissions on the right. And all the options to filter and toggle the data on the right side of the dashboard change the graph here on the projected side of the dotted line. So that's what we're going to focus on, is what all this means and what it will do to this graph. The first thing you can do is filter the graph by sector. So if we want to look at just an individual sector, we can deselect all and highlight, for instance, Austin Energy, and only that sector will be displayed. And an important note is the target will also proportionally scale to the sector. So if you select a small sector, it'll have a proportionally small target. And we can also stack different sectors. And the targets are proportional to the 2018 emissions. So it just takes that year's share of emissions and proportions the target to that year. The next thing we see is this color legend. So these are the different sectors and what color they correspond to. Below that is target display, which allows you to change the target. So there's about 5 possible targets on here now, and we can see what different ones look like. The first radio button below that, graph display, allows you to, this is an important selection, to change the graph from a business as usual or no action scenario, which is original projections, and adjusted projections, which then allows the graph to take into account all the changes on this right side. So if we want to just quickly snap back to what happens if we do nothing, we can select original projections. Otherwise, we want to stay in adjusted projections. Another quick toggle is this transportation growth option. And this just shows what would happen with no transportation growth. So you see it just slightly flattens the transportation growth over time. And this is just another quick toggle to say, we know we fully expect transportation to grow in the future, but if it didn't, it would look something like this. So I would keep it on normal growth. The third radio button is how to display negative emissions. There's really 2 ways to display them. We can either show negative emissions. So we want to be in adjusted projections if we want to see items on the right side of the graph. We can either show negative emissions below the 0 line and then positive emissions above the 0 line, or we can sum those both together. So we'll essentially apply the negative emissions to the positive emissions to see what the net emissions would be. And that's what this show net option does. It's just, it'll take whatever's negative at the time in either natural system sequestration or offsets, and then apply it to the positive side. Moving on, there's 3 big categories of emissions toggles up here. The first one is electric vehicles, which is the most impactful single action on the graph. So this graph shows the adoption curve for light-duty electric vehicles or heavy-duty electric vehicles in the community. And we can change these curves using these sliders. Or if we want, we can just look at low, medium, and high scenarios by pressing the buttons for both light duty or for heavy duty. And these will update their emissions in the graph. Similarly for transit, we can adjust the percent change, the increase in transit rides that we project over the next 10 years, and then also change the way that adoption curve looks with similar size start and curve options. The size is the amount, how drastically it will increase. To the left is increasing faster, to the right is a flatter increase. Starting to the left is starting earlier, starting to the right is starting later. And then a curve just flattens or makes the curve more steeper. Moving on to the teleworking section, it's useful to explain teleworking and biking in a similar way because they're both modeled after a commute to work. So the number of teleworkers would represent the number of people teleworking and then multiplied by a number of days per week over the year. So one day would be, in this scenario, 43,000 people teleworking 1 day a week or 52 days a year. Similarly, it's bicycling increase in the community is modeled after a commute-based calculation. So this is 64,000 people biking to work 2 days a week. And there are other ways to model bicycling. Obviously, people ride bikes other times than to work, but this is just a simple way to think about the amount of trips that would have the same effect on transportation emissions. Below that, we have quick options for the next four sectors. So Austin Energy has a low or high emissions scenario that may or may not happen. Either one could happen over the next 10 years. As far as natural gas in buildings, we think that we could have no action, have some limited new natural gas, no new natural gas, or various degrees of electrification of existing buildings. So existing buildings that have gas being retrofitted to not have gas. And those all have different emissions curves that you'll see on the graph. Refrigerants similarly has three options. So no action, moderate transition to lower leak rates, and lower global warming potential refrigerants. And industrial emissions have a similar path. So either no action to reduce high global warming gases used in semiconductor, mainly manufacturing, or fully abating them, where you'll see here they're fully gone by 2030. All of these are applied with an adoption curve, so it doesn't all just happen 1 year. We assume it would happen over time. The last options are for negative emissions or potentially negative emissions. So if we purchase offsets, you'd see that in this light blue color, and that's also scaled to phase in over time. So the 2 million number we have selected here is what we see in 2030, but it's only half that in 2025 and 26. So it comes in over time. Natural system sequestration can either be positive or negative. So if we lose some carbon that is currently sequestered, for example, if we have a wildfire that burns a lot of trees and that releases a large amount of carbon in the atmosphere, it would be negative, and you'll see that increases the overall emissions. Or if we sequester more carbon, grow more forests or trees, or have more carbon sequestered in ecosystems, then that would be net negative emission. And so again, these are useful to use the negative emissions toggle, which can either show the net capability of all of the emissions combined, or show positive and negative for display purposes. That's it for now. If you have any specific questions, feel free to email me, and I hope this is a useful tool for you.